Welcome to Unit 6A Video Lesson 4. The reading to go along with this video is from Chapter 6, Section 4. You're going to be reading the headings Polar Coordinate System, Coordinate Conversion, and then you're skipping a heading and going to Finding Distance Using Polar Coordinates. So what is the polar coordinate system? Well, you're used to a system where you have x, y. This is called the rectangular coordinate system. Because it's essentially rectangular. It's all about right angles. You're going right some and then up some to get to a point. In the polar coordinate system, instead of x and y, you have r, which is your radius, and theta, which is going to be your angle. The angle is measured just like usual in the standard representation. So you start at the polar axis, which is essentially like the positive x-axis, if it were placed on top of my rectangular coordinate system. And instead of saying how far right and then how far up or down, or how far left and how far up or down, you're saying how far out on the radius, and then how much is that radius going to be rotated clockwise or counterclockwise. Counterclockwise is positive rotation. Clockwise is negative rotation. Just like usual, standard representation of an angle. So how do we actually plot some of these points? So let's practice. We're going to plot A through F. Some of them I'm going to plot for you, and then some of them I'm going to give you a moment to try it on your own before I show you where that's going to be. Okay, so point A, radius for rotation of 60. Even though radius comes first, I personally like to find my rotation first. So I'm going to figure out, I'm going to rotate to this 60-degree rotation line. And then how far out on that rotation line am I going to go? 1, 2, 3, 4. That's point A. I'll leave point B for you to try at the end on your own. Point C is a little bit different because we've got this negative angle. Negative angle means we're going to be rotating clockwise. So, find your rotation line first. Here's my polar axis. 30 degrees in the negative direction gets me to this 330 degree area. And out this line I'm going to go 1, 2, 3, 4, 5. That gets me to point B. That gets me to point C. Now let's try D. D is weird because we have a negative radius. That means instead of going out in the direction of your angle, we're going to be going in the reverse direction of an angle. So let me show you what I mean. You're going backwards. So let's first find my rotation line of 225 degrees. I look around here and here's 210, here's 240. There's 30 degrees between them. So that means this to here is a 15-degree rotation. 15 plus 210, hey, there's my 225. So that's my line. But where do I go along that line? I'm going -6. So along this line, instead of going towards my 225 degrees, I'm going away from it. 6. 1, 2, 3, 4, 5, 6. That is point D. I'm going to try E with you, and then give you some chance to try B and F and figure out where those are on your own. Point E. I first find my 120-degree rotation line. That's right here, 120 degrees, but instead of going towards 120 degrees, I'm going backwards along that same line, -5. 1, 2, 3, 4, 5. That is point E. Now I want you guys to pause this and try finding points B and F on your own. Pause the video right now. Are you back? Let's see if you graphed B and F correctly. There's point B. There's point F. Did you remember to go backwards from your 90 degrees since it was -7? Did you count the 7 correctly? Did you count this tiny circle as 1, or did you accidentally skip it? I hope you got them right. Now, let's talk about something else about these points. When we had our rectangular coordinates, you had one coordinate, and that was the only way you could get to that point. With polar coordinates, not so much. We're going to figure out how else we could name point A. Now, in order to figure that out, I'm actually going to start by looking at point E. I know that's weird. But when we were graphing point E, notice that that was -5, 120. But when you look at the point, it looks like it's on the 300-degree rotation line, because we were going backwards from 120, because it was negative. So how can we apply that idea to renaming point A? Well, we could make it -4 instead of +4, and instead of 60, we can think of this as going backwards from, going along that same line, to 40. Now, where did we get 240 degrees algebraically? Well, 60 plus 180 gives you 240. The negative can be 180 degrees away from the positive R representation. Now, the other way that you can change these is you can find coterminal angles. Remember those from last semester? Coterminal angles are full rotations away from each other. So something coterminal to 60 would be 60 plus 360, or plus 360 times 2, or 360 times 3, or 360 times any number n that is an integer. So we could say 4, 60 plus 360 is going to give us 420, because 420 degrees is coterminal to 60 degrees. Or we could have subtracted 360. That's 360 times -1. 60 minus 360 means we could have said 4, -300. So there are many ways to name how to get to point A. Now keep in mind, if we were dealing with radians instead of degrees, we could do pretty much the same thing. For the negative version of R, instead of adding 180 to your angle, you can add pi. For the coterminal angles, to find other positives if you started with a positive, or other negatives if you started with a negative, instead of adding 360 n times, you can add 2 pi n times. So it's the same idea whether you have degrees or radians. And yes, we are going to be dealing with radians. Sorry, guys. Warning! You need to remember stuff from last semester. So let's see what you need to remember from last semester, other than just, what are radians? Oh no! Well, here's one of our special right triangles. 45, 45, 90 triangle. Remember, 45 degrees is the same as pi over 4. We can label this triangle using a root 2, but remember that when you're finding the sine, cosine, tangent of 45 degrees, it's easier to think of it in terms of the simplest triangle that doesn't have variables. I make the smallest side 1. 1, 1, and the square root of 2. You can do the same thing with a 30, 60, 90 triangle. Remember that across from your smallest angle, 30 degrees, will be your smallest side, 1. Across from your largest angle, 90, is your largest side, 2. And then across from 60 is going to be your root 3. Remember this from last semester? Next thing is something else that you had to put on that add to your formula sheet for the semester exam for semester. All seniors take calculus. And my pen is being wonky. That tells you where the positive values are. All is positive, sine and cosecant is positive, tangent and cotangent is positive, cosine and secant is positive. So let's apply that. We're going to evaluate sine of 5 pi over 4. The first things I'm going to note are, well, 5 pi over 4 is in the third quadrant. I know because 4 pi over 4 is pi, or 180 degrees, here, and 5 pi over 4 is just a little bit more than that. It's here. Next, I'm going to note that the reference angle is pi over 4, or 45 degrees. So this is going to mean, third quadrant, sine is negative, and it's going to be the negative version of sine of pi over 4. 1, 1, root 2. If I haven't completely memorized that chart, it's way easier to remember the triangle. And I'm going to say, all right, it's negative, and then sine of pi over 4 is going to be y over r, 1 over root 2. And of course I know that I can't keep it that way. I multiply numerator and denominator by root 2, and I get negative root 2 over 2 as my final answer. For cosine of 300, yes, we're going back and forth between degrees and radians, deal with it. I think, what quadrant is that in? Well, 300 degrees is 60 less than 360. So that tells me I'm in my fourth quadrant, where cosine is positive, and my reference angle is 60 degrees. So we have positive, and then in my fourth quadrant I can draw my 60 degree reference angle and say 1, 2, square root of 3 cosine is x over r, so that's going to be positive 1/2. And lastly, I'm going to have cotangent of negative 7 pi over 6. Ooh, it's a negative angle. Yes, you're going to be dealing with those. Negative means I'm going to be going clockwise. 7 pi over 6 is a little bit more than 180 degrees, so it's negative pi plus another pi over 6. Because 6 pi over 6 plus pi over 6. So a little bit more than 180 degrees clockwise gets me into the second quadrant. So my reference angle is pi over 6, or 30 degrees. I draw my triangle. I think, well, cotangent is the same as tangent, only the reciprocal, so the positive negative value is the same. So that's going to be negative in the second quadrant. Pi over 6 is my reference angle. So we're going to have negative, cotangent is x over y, square root of 3 over 1, which is the same as negative root 3 as your final answer. Remember that? I am going to be giving you a formative assessment as an either entrance pass or exit pass, depending on how much you complain, to see how much you remember this tomorrow in class. Know your special right triangles. Yes, it will be graded for accuracy, and yes, it might be the exact one that I gave you last October. Yeah, think about it. Now, how do we convert from polar to rectangular, or rectangular to polar coordinates? Well, you do have these lovely equations that we already should know that are not on the formula sheet. I repeat, not on the formula sheet. Because these are things that you really should already know about x and y coordinates and the relationship between the radius and the angle. You should know from last semester and more recently from our vectors that an x-coordinate, or component, is r times the cosine of theta, and that a y-coordinate is r times the sine of theta, because sine is that vertical component because it's opposite the reference angle. You should already know from Algebra 2, and more recently from just a couple videos ago, that x squared plus y squared equals r squared. Remember, that's the circle at 0, centered at 0. And you should already know from last semester, and more recently from vectors, that tangent of theta equals y over x. They're not on the formula sheet, but they tell you the relationships between x, y, r, and theta. If you're looking for x, y, and you know r and theta, that means you're going polar to rectangular. And those are the two formulas you'll need. If you know x and y, and you're trying to find r and theta, that means you're going from rectangular to polar, and these are the two equations that you need. Right here. So let's do two examples together and one on your own. We're going to find the rectangular coordinate of the point with the polar coordinate 2, 7 pi over 6. We're going to need to find an x-coordinate and a y-coordinate, so we use the x and y equations. X is r times the cosine of theta. Y is the radius times the sine of theta. Now, I always like to draw a little sketch, thinking, okay, 7 pi over 6, that's in my third quadrant because it's pi over 6 more than pi. I think, okay, my reference angle is pi over 6, so 1, 2, root 3. And I can think, alright, all students take calculus. I don't have any tangent, so these are both going to be negative. Cosine is 2 times negative x over r. Sine is going to be negative y over r. So my x-coordinate, my 2's canceling out, is negative root 3. My y-coordinate with my 2's canceling out is negative 1. So my final coordinate is negative root 3 comma negative 1. Done! Now how do we do that with going from rectangular to polar? Slightly more complicated, but not by much. We still need a formula for theta and a formula for r. The formula for r is x squared plus y squared equals r squared. In this case, negative 4 squared plus 3 squared equals r squared. 16 plus 9 is 25, so r equals 5. For our theta, you have tangent of theta equals y over x. I know how to write an x. In this case, tangent of theta equals negative 3/4. Now, I am not going to make you do that in your head because 3/4 is not something from one of our special right triangles. So you can do inverse tangent of both sides. Inverse tangent of negative 3/4 gives you negative 6.4350 radians, or in degree mode, negative 36.86. So you're saying that tangent of theta, when we do inverse tangent of theta, we're going to get, now I've forgotten them again, negative 36.86 or negative 0.643. But however, that would put me in the fourth quadrant. And that's not what I want. I want negative 4,3. That's in the second quadrant. Oh yeah, tangent is negative in both of those, and inverse tangent only gets me these two quadrants, from 90 degrees to negative 90 degrees. So we have to then put it in the correct quadrant. So we have 180 minus 36.86, which should give us, from my own notes, 143-ish. And pi minus 0.643, which should, from my notes, give us approximately 2.498. So that would be degrees and radians. These are the correct answers. These are not correct. You would not be done if you gave me those answers, because they must be in the correct quadrant. Okay? Now, your turn. Convert these polar coordinates into rectangular coordinates. Pause it and try it on your own. Are you back? All right, let's see if you got it right. Ta-da! And there's the answer. Did you think to draw in the correct quadrant? Did you get that sine is negative in the fourth quadrant and cosine is positive? That your reference angle would have been 45 degrees? I hope so. Here's your final answer. Now, the original plan was to cover one more topic about finding the distance between two polar coordinates, but I think that maybe you've watched enough video for now. So I'm going to cover that a little bit in class tomorrow. before we start our practice. And then if you miss class, if you are going to be taking an AP test, I will have a separate video for you to watch that's just covering that topic. I'll see you tomorrow. Bye.